Hi everyone, Sertalp here. Today I will be talking about how to use Python to solve a single period FPL optimization problem. So in this video we will be talking about again the expected points and using some data sources like official FPL API. We will combine them together and then we will define our optimization problem. We will talk about what are our decision variables, what are the constraints, what's the final objective that we are trying to optimize, and then we will talk about how to make it more efficient, how to make this process more efficient, and I will try to cover this in a short amount of time. So in the earlier video, I used Jupyter Notebook. I'm still using Jupyter Notebook, but I will be using Visual Studio Code as my editor, and it has the Jupyter Notebook capabilities by itself, so you can install the Python extension to it. And then that's what I will be doing. And on the right side of the screen, you will see the task that we will go over, and so it will be easier for you to follow along. I have already downloaded the data from FPL Review. You can go fplreview.com and then download the projections for the next coming weeks. So in this video, since I will be talking about only a single period FPL optimization problem, you can just download the data for a single week. The data I have has I think 3 weeks of data, but it doesn't matter as long as you download the next available data. And so let me share my screen now. So as you see, I am on Visual Studio Code. I am inside the folder that we have created last time together, FPL Python optimization. And under data, you will see that I have already downloaded the FPL review data, and if I open it, you will see that this data has the position, name, and then buy and sell values, which we won't be using here, and then the team information, and then finally you see here we have expected minutes and expected points for every player. And so this is the column we will use essentially. So let's create a new notebook. Let's call this tutorial 2 and then a single period FPL P, Y, and B. Alright, so we are in the development environment. Let me close this too. So here, let me start with importing the packages that we will use. The first package we will use is pandas. And the second one is, you can remember from the last time, is sasoutpy. Again, you can use any optimization modeling package you want. So most of them have a similar structure in terms of how you define the problem. And import requests. So we will be using request package to make queries to official FPL API, and you will see that in a second. And I will also import OS for running this CBC solver. And finally, I will import time here because I will measure time, how long it takes for us to model and define the problem and solve it. So when I do shift enter, again, as you see, it went through. Here you can check your sasoutpy version like this. So it is __version __. As you see, I'm using 1.04, which is the version you should be using to use MPS export abilities. But anyway, so let us start with actually data. So here, if I expand here, you will see that we have two data sources we will be using in this tutorial. The first one is the official FPL API. The second one is FPL review. I already mentioned that I have downloaded the FPL review data, but essentially what you need to do is going to the fplreview.com and then choosing either massive data or implied odds from the menu, enter your team ID, choose how many weeks you would like to get the data for, and then click download CSV file. And then you can put it to a folder like this and then rename it so that you will know what it is. So I have already completed this step, so I will be marking it completed. And here now I need to find the official FPL API data. For this, you can go to FPL Optimize. I have a tab here showing the FPL API endpoints. If you click on it, you will see all the FPL API points that we know. The first thing here is actually returning us lots of information about the upcoming events, like meaning the games, game weeks, and then the player information, team information. So this is quite a big amount of data. Just copy this address here, okay, and here I will say r is equal to request, and then I will make a get request to this URL. So what's happening is request package is going to go to this address and get the solution back to us, and here our FPL data. So, and you might be familiar with this notation, but this is a JSON representation, and so it is easy to convert it to native Python object types. When I do shift enter, again it went through. You can actually see what FPL data includes using keys method. So as you see, we have events, game setting, phases, teams, total players, elements, and the elements is actually the list of all the players in the game. And so that's the data we will be using. So we will use elements, we will be using teams, and we will also use element types, and you will see that in a minute. So instead of listing the keys, let me get the element data. So I will get this elements object, and I will convert it to a pandas data frame. So I will call FPL data elements. Again, it went through, and you can actually see what kind of a structure this thing has. So you can call head on the data frame object and see what are the columns. So we actually converted this data into a table structure. These are all the data available on the official FPL website, and so it is in a tabular format here. So I will do the same thing for teams. Actually, let me call this team data, PD data frame, FPL data teams, and then let's show the head. Again, here you are seeing the team names, and then they're like short names, and then so this table, for example, have already like strength defined by FPL itself, which we won't be using here, but it could be handy. Next is, so again here we are able to see the table, but you will see that we have 3 dots here, meaning there are more than like more columns than we are able to see here. Let's have a look at how a single row looks like. So if I call this, then you will see that we have more information, and actually I can call keys and I can see all the information, like there's a web name column that we will be using to identify which player that we are talking about, and you can also see the team somewhere, yeah, team code and team. So these are for identifying which team this player plays for. And so what I'm going to do now is I will combine element and teams data. The reason being is, so if I actually check this element data log 0, so this will give me the player at the 0 index, and then if I say team, you will see only a numeric value. It's the same thing with the team code, as you see, because this data doesn't have the team name explicitly spelled out. So what I will be doing, I will use this team data which has the team name, and it also has the team ID and team code over here. So we will combine these two data frames into a single one. So here I will say elements team is pandas merge, and here I will be using element data and then team data, and then on the left side I will say use team, on the right side use I think we need to use ID, yes. So similarly, you can use code and team code on the left table, but yeah, this should do the trick. And when I press enter, you will see that it went through. Actually, let me show you what a single row looks like. In order not to see like these three dots, so let us call pandas option context, and let's say display max rows none. Here we are saying that with this option enabled, run this command, and right after we leave this with thing, it will revert this option back to its default value. So let's see elements team dot log 0. Okay, so this is the first player in the table, and you will see that some of the columns now have a suffix underscore x if it is coming from the first table, and underscore y if it is coming from the second table here. You will see that, so this is Mesut Özil, even though he's not in Premier League anymore, he's listed as one of the players, and you will see everything related to it. And after a certain column, you will see this underscore y, and as you see, we have the code column and then the ID, and this is the information we are interested. So now we know which player is playing for which team in the string format. So we are good, and let me continue with loading so we completed FPL API step 2 and also data sources. Okay, next is using parameters. Let me also show the completed items here, and so we can see which steps we have completed so far. And the next thing we will do is we will combine the FPL review data with this data we have. So first of all, let me read this. Review data is equal to pandas read CSV, and remember it was inside the data folder and it was named review.csv. And then let me print out the head. It's running, and okay, here we go. And you will see that actually this order that FPL review is giving the data is actually the same order that we get our elements, but we will be merging them using this name column anyway. And here you will see that, so this is the data we have just checked, but yeah, this is the column we are interested. And so we have this data and we have this data. Now what we need to do is we need to combine these two together so that we can have refer to it. So some of these steps might not be required for certain problems, but this comes very handy in the future steps, and when we especially model like bigger problems with more constraints. So let me merge them here. Merge data is equal to pandas merge. So we have elements team, which is already a merged table, and then I will merge this with review data. On the left side, we will be using name. So remember, this was the name of the team inside this table, and then the player name are like noted as the web name, and we can actually check if this is correct. As you see, web name is Özil here, which I will be using, and on the right side here, it is the team name is written as team, and then the player name is name with the capital N. And if I run this, I should get the merge, but again, let's call option context again, do the display max rows equal to none, and then print merge data. And this time we can actually let me just check a player who is playing this week, and I will say filter this table by like find Salah in the merge table, and this table should include only a single entry and get the get the data in the like very first entry. If I do shift enter, you will see that we are getting Mohamed Salah's information. Again, you will see that we have the correct the team name here, and so these information now is added at the end of this table. So we have so this is the actually the field we will require. So we have merged data ready, and we already displayed the content of it. So before we move further, let me go back here and show you that we have this IDX column, which is 254 for Salah. So this is a unique identifier of a player, and we can use this as an index. So we can call this table using this ID number, and we will know which player we will be talking about. For this purpose, I will say merge data set index, and then I will call this IDX as my index, and I will say replace this index in place, so we don't need to create another table. Shift enter, and it worked. And let me also get the next game week. So here what I will be doing is so I will see we already read the review data here. What I will do is I will get the 0, 1, 2, 3, 4, 5. Look, 5. So I will get the fifth column here, and I will split it using the underscore, and I will read this data. So this number should give you the next game week, next upcoming game week. So again, here it might not make too much sense because we can hard code 30, but this will be useful once we model the other problem. So I will say review data keys and get me the fifth one here. And so after getting this, split it with underscore and get the first part of it. And let me also print this information to see if it is correct. Yes, so we have 30. And again, when you download a new data set for the upcoming week, so you should see the correct game week number here. So so we are actually ready. So let me open these parameters, and we already have the player ID, we have received the name, we know the teams, and we will see in a minute, but every player here has an element type, which is also mentioned in the element types entry. So we will in a second we will be doing this. And for price, and you will see this column here, now cost, shows the price. So you need to divide this by 10. So 124 means actually 12.4 is the current price of Salah in FPL. So we have this data already, and we added expected points. So before I move forward, then I need to get the type data from and I need to also convert it to a data frame. So I need to go to FPL data and get the element underscore types. Remember, this was one of the keys that we mentioned that we will get, and I know what this table looks like, and I know that there's an ID column which is equivalent to this element type. So this will the ID will go from 1 to 4. So I will use this as the index at the read time, so it will be easier for me. Let me print the head, and you will see that for every type we know which type it is, like what the actual name is. And here FPL API even shows you what are the conditions. So you need to have two goalkeepers, 5 defenders, 5 midfielders, and 3 forwards. And again, here are the lower and upper bounds for the valid lineup. So you cannot have less than 3 defenders, 2 midfielders, or 1 forward again, and you can see the upper bounds for a valid formation. So now we also have the position data, so we actually completed parameters. So now what we will be doing is we will define our model. So I will call this let's call it model, so it will be easier for us to refer single period. Okay, so we have our model, and then shift enter, initializes the optimization model here. And so next is actually creating the indices. So for this, the first one is, I will say players is merge data and get the index and convert it to a list. Remember, the index of the merged data set was IDX column, which gives us a unique numeric identifier for every player. And similarly, I will say element types is coming from this table over here, type data index to list. Shift enter, and we have our indices. Now we need to define our variables. Oops. Okay. Let me delete this one. Okay. So as you see, we have 4 different variables. The first one is the squad. So this will be a binary variable showing whether we have a particular player in our squad or not. Lineup, again, whether we have this particular player in our lineup or not. We need to choose a captain and a vice captain. So as you see, I'm not taking bench into consideration, but I know that if a player is in the squad but not in lineup, that player should be in bench, so we don't need to create a separate variable for it. You might want to use bench as a separate variable, so you can also track the order of the bench players, but I will cover that in the next video. So let's keep things simple here, and let's call this squad is my variable representing whether I have a player in the squad or not, and I will say model.add variable. So the first thing I need is an index, and I know that players is the index set for players, and I will name this variable squad. So this name will be used inside the optimization representation. That's why it is important, and I will say so.binary. So this will create a binary variable for it. Similarly, let me do the same thing. Actually, let me copy this. And so we have the lineup. So this is the only different thing is here. Again, let me copy this. So the next one is captain. And finally, vice captain. And this is vice cap. Okay, shift enter, and we have our variables. So I think we also forgot to get the teams as a list, so let me do it here. So we need to read the team data, and here in the team data you see that we have, sorry, not here. Did I print it? Yes, here. So we have the name column listing all the names of the teams. So I will get that one as a list too, so that I can refer to it inside when I'm defining my constraints. Okay. We are here. So now we have defined our variables, right? We defined a squad, lineup, captain, and vice captain variable. Okay. We are done with the variables. Now we need to go over the constraints. So we have plenty of constraints here. The first one we will do is we need to make sure that squad count is equal to 15. So what I will be doing here is, so I will show you how we can count this. So this is the squad count, and in assess_opt_by you can use this summation expression expr_sum, and you can sum a particular set of variables. Here we need to iterate over squad, so I will set squad p, and p will refer to the player index, and I will say for p in players. So this is an expression, so this will give us the summation of all the squad variables, and since they are binary, I know that this summation should be between 0 and over like 600 every player, and we will limit this. So let me run this. So we have squad count as an expression, and you can also see what the expression looks like. You see it's a summation of all the of everything, but so here I will say model.add constraint. So this is a single constraint, so we are using the singular form, and I will say squad count, which I calculated here, should be equal to 15, and then the name will be squad count. Shift enter, and then you will see that the same expression and then it will have equals to 15. So let me put a semicolon here so that it won't show the entire constraint. And the next thing is, so we check this. The next thing is making sure the lineup count. So I will use the same technique actually. So, but instead of like defining it as a separate expression, I will do it here. I will say expression sum, and then lineup p for p in players equals to 11. So we need to have exactly 11 players, and this is the lineup count constraint. We added this constraint to this, so we need to choose a single captain and a single vice captain. Let's do it. So we will say add constraint, again expression sum captain p for p in players should be equal to 1. This is captain count, and let me copy and paste this so that we can use the same thing for vice captain, and then this should be vice cap count. Okay, so we handled these two. So these constraints, actually, these lineup, starting with the lineup player must be part of squad. These are actually constraints that relate multiple variables at the same time. Like, for example, the first constraint says lineup player must be part of the squad. So this goes without saying, of course, but the model doesn't know, so we need to add this as a so this is a set of constraints, because we need to enforce this rule for every player in the squad. So I will use model.add constraints, and then I will open parentheses. Here you need to have a generator type object. That's why I need to open another set of parentheses and write lineup p should be less than or equal to squad p, and then here I will say for p in players, and then the name will be lineup squad relation. Here again, let's reiterate what we are doing. So this is a binary variable. This is a binary variable showing whether we have a player in our lineup or squad, right? So we are saying if lineup is 1, okay, then this constraint becomes 1 less than or equal to squad. If we have a player in lineup, it will force that player to appear in our squad too. So the reverse could be true. So you can have a player in your squad but not in your lineup, meaning a bench player, but the reverse is now forbidden. If you have a player in your lineup, he should be in the squad. Okay, and so this is the first one, and then the second one is actually very related. It says captain must be part of lineup. So I will just copy this, and I will say captain and lineup has the same relationship, and let me call this lineup captain lineup relation. Similarly, we have the same relation for vice captain. So vice captain should be less than or equal to lineup for p in players, and then let me fix the name. So this is done, this is done. And then captain and vice captain cannot be the same player. So this is related to choosing the captain and vice captain. So what you need to do here is take captain and add vice captain. So again, these are binary variables. So this could be 0 or 1. This could be 0 or 1, but not at the same time. So this summation, then we know that is always less than or equal to 1, which actually restricts, and so we cannot choose the same player for both captain and vice captaincy. And I will put a semicolon here, run this, so we have all the constraints now. Okay, so now we arrived at the formation constraint. Formation constraints are actually a little bit different because we need to define a range for these constraints. So think like this. So we will have an expression that both has a lower bound and an upper bound. Remember, from the data we have this squad minimum in play and maximum in play. So for this purpose, what I will be doing is I will create a dictionary, and I will use this dictionary inside my constraints later. So I will call this lineup type count. So this will count how many types of a player I have in my lineup. And I will open this, and the key of the dictionary will be T, referring to type, and I will say this is equal to an expression sum, and I will sum lineup P, okay, just like we were doing before, for P in players. If I do it this way though, it won't work because we don't know what T is, and we are just basically summing up all the players, right? So here I will say that this is for T in element types. Remember, element types was a list of types, so this goes from 1 to 4 essentially. It's just a numeric value. But if I do it this way, then I'm summing all the players, not only this set of players. So that's why I will use an if condition here, and I will say if inside the merge data table, and I will use location function. I will be using the player index P, comma, and then I will be using the column called element type. I want this value to be equal to T. So as you see, so we have an expression sum here, which we iterate over players, but then we are also adding an if condition. Now this will give me a dictionary, and you will see it in a second. Let me print this. So the first key, the goalkeeper, is actually an SysOpy expression now, summing up all the goalkeepers in our data, and then it does the same thing for defenders and then midfield players and everyone. But essentially we have what we needed, and I will actually do this same thing for squad type count, and only thing I need to change is the squad here. Okay, so we have a way to count lineup players by their types, and then the squad players too. So I have these two dictionaries. Now I can add the constraint. Model add constraints, because we need to write this constraint for every type separately. And when this says that formation should be valid, again, we are going over all the different types, right? So here I will say model.add constraints, and then open parentheses and another set of parentheses again, and call this dictionary here lineup type count T. And here, remember, we were using like either equality or less than or equal to, or in some cases greater than or equal to. Here, what I will be using, again, equality, but instead of a numeric value like 15 or 11, I will give a list with 2 elements in it. If I do it this way, then SysOpy knows that this is a range constraint. So there is a lower bound and an upper bound. So, and what are our bounds? It is coming from type data. I will say locate index T and get squad min play. So this will be our lower bound, and also get the upper bound type data dot location T, and then use squad max play. And here I need to add a name to the constraint. Let's call this valid formation. So inside this second set of parentheses, we need to say for T in element types. Let's try again. Okay, see, we have the constraint. We have actually a set of constraints. Am I missing anything here? Let's see. No, okay, see, so these are representing the goalkeeper, so it's summing them up and making sure that inside my lineup I only have exactly 1 goalkeeper. And then for defenders, you will see that it is saying equals to 3, 5. So this is the lower bound, 3 defenders and maximum 5 defenders. This is the valid formation constraint, and then the second one is count per type must be satisfied. So we need to have 15 players, but they need to be certain types. So this constraint is actually very similar to this one. What I need need to do is squad type count, and then here, instead of giving a range, let me delete this entire thing here. I will say this one is equal to type dot locate the type, and then we need to use squad select, I think. Yes, squad select is how many players you can have, and this is a valid squad. Okay. So the next constraint is we cannot exceed our budget. So we don't know the budget, but let assume that you have 100. And so what I will be doing then is model at constraint. So this is a single constraint, and we will be summing up. But actually, even before this, let's using the budget. Let me calculate the team value or team cost, if you would like to call it that way. But this is essentially expression sum, and I will say let's call this price, so we will know that this is the total price of all the players. I will use merge data, and I will choose get the location for a specific player, and remember the column name was now cost, but we had to divide this by 10, right? 10, and then I will say multiply this with the squad.p, because this is either 0 or 1, so you will either get the full cost of the player or 0 if you haven't chosen that player for p in players. Okay, so we now have price and budget. Now it is very easy for us to write the constraint. At constraint, I will say price should be less than or equal to budget name budget limit. Okay, here you see that we are multiplying the current value of every player, and then making sure it is not exceeding the budget. Now we have done this, and the last constraint is making sure we don't have more than 3 players per team. And so this constraint requires for us to iterate over teams. So I will say add constraints, and here we need to count how many players we have from a specific team, right? So I will add a new parenthesis, and I will write the team limit, the name here first. So this will iterate over t in teams. So for every team, now we need to count how many players we are picking from that particular team. So I will use again expression sum, and in this case it is squad p for p in players. And as you can guess, we are going to use an if condition. I will say merge data, find the player, check the team name, and the column representing the team name is named name. So if this is equal to t, then we are getting this expression sum. So what do we want? We want this summation to be less than or equal to 3 for every team in our team list. And let's see, yep, we then modeled this one. Our constraints are now completed. Okay, perfect. The next thing is our objective, and for objective we need to calculate total points. Okay, total points is essentially your summation of your lineup plus your captain, but we also would like to give some weight to the vice captain. So when I'm saying total points, then this is kind of a measure for you to be trying to that you are trying to maximize, but doesn't necessarily mean that the total of the expected points. We will calculate it in a different way in a second, but what I will do is I will again call this an expression sum, and here what I will do is I will find the player first, and I will be using the player's points for the next week. So instead of 30 here, I can use next game week, because remember we were already saving it. And I will put an f in front of this string here, so converting this into an what's called f string. So this will replace next game week with value 30 at runtime. So now we have the points for the next game week for this particular player, and I will multiply this with summation sum of lineup p. If you have this player, then you will get one multiplier, and if that player is your captain, you will get another one. So this will make your captain points to be multiplied by 2. And if that player is your vice captain, let's put a weight like 10%, vice cap p. Okay, and here I am multiplying this, but I need to say that this p index is inside players set. Let's see. Total points is merge sum next game week points, lineup, captain, vice captain. Okay, yeah, this should be correct. Let me run this, and you will see that the full expression is actually including everyone and multiplying their points with the vice captain points, lineup, and everything. Okay, let's delete this, and now we have total points here. What we will do now is setting the objective, of course. Yeah, maximize lineup and captain selection. I will say model that set objective. Remember, when we are working with CBC, it only minimizes the objective. So and in this case we are maximizing, so we need to give the negative total points, and then I will call this sense n, because that's how it accepts, and I need to give this a name. I will call this total XP, and then you will see the entire expression. I will just limit this output, and finally here we define our objective, solving and parsing. So for solving the problem, we will first export problem into NPS format so that the solver can read it. We will solve the problem using CBC, and then we will parse solution back to the file. So what I will do is I will say model.export NPS. Here, let's call this single period.nps, and then it will just export this as a file. And let's open, and you will see that single underscore period.nps is created. So if you open this, you will see that the whole expression is here, all the variables and everything. Let me close this, and the command we will be using is cbc, and then we will call single period.nps sol.u and solution.txt, meaning that we want solution to be generated as solution.txt. We were using the same name for the goalkeeper problem, so let's call this solution single period underscore sp. And I will run this, and I will use this notation coming from the Jupyter Notebook, and when I run this, you will see that we exported the problem and we solved the problem, and this value here, 62.87, is summation of all the expected points for lineup, captain, and vice captain with their weights. So as you see, solving the problem took almost no time, and what I will do is now I will read the solution back. So we did this part, we need to read the solution back to the file. Before reading it though, let's actually clear all the variable values, because if you do this multiple times, we need to make sure that values are not like being overridden. So I will say for v in model.get variables here, v.set value 0. Okay, so we cleared everything. Everyone has 0 value now. So I will say with open solution underscore sp.txt and open this file just to read it, not to write it, and I will say as f is our now variable, and I will say for line in f, and actually let's check this file. So as you see, it shows the optimal objective value, and then the first row, and then the rest is actually showing our variable names. So again, I will check if this word, if objective value in line, then you don't need to parse anything because it is only the first line of the file. If not, then I will actually split line using the white spaces. So when I do it, I will get 65 and then squad 53, 1 and 0 separately. And here, this is the index of the variable. This is the variable name which we will be using. And this is the final value of this variable. And so this is the value we will be using. And this one finally is the effect of that variable in the objective value, which we won't be covering here, but yeah, it could be useful. So let's split the words and then find the model. So for this purpose I will use get variable, and here as you see we need to pass the name, and in our case when we split it, this is column 0, this is column 1, that's why I will be using words 1. And then when we get the variable, now we can use set value, and we will be getting this column, right? So this will return as a string, so I need to convert it to a float value. So I will say use words2 and then set value. Okay, so we read the solution, we have everything we need, so let's create a new data frame. So for this purpose, I will first create an empty list, and I will be using this list with lists. So this will be a two-dimensional list that we will eventually convert to a data frame. So let me iterate over all the players, and I will say if, for example, let's start with this way. If squad P that get value is greater than 0.5. I mean, this means just like equal to 1, but because of the potential numerical issue, so we can use just 0.5. Print the player's ID. Let's do it first. As you see, we have now 15 players listed here. So this is good. So what we need to do is getting the player's data. Let's call this like the player's LP data. Use merge data and now find location of the player, and then maybe print LP dot or name, or maybe web name. Sorry. So we can see the name of the player. As you see, now we have the list of all the players. Now we need to get the necessary data out of this. Let's call this is captain is 1 if captain P get value else 0. So this is captain is either 1 or 0 in this case. So I will use the same logic for lineup and vice captain. Is lineup if the lineup variable is also 1, is vice captain is vice cap. It is that way as well. Now we will add this new list into our picks list, and here I will be using first of all the web name like we used, so we know the name of the player, and we also need to get the type. For type we can use actually LP element type. So remember, this is a numeric value, so it will only show us 1, 2, 3 or 4. If you don't want this, then you can also get the position this way. So you can use type data.log and then find the player's type index and then get the singular name short. Remember, this was showing like just the brief notation, like goalkeeper. For defenders it was DEF and everything. So you can use element type here instead. Here let me put position and keep the element type, so it will help us with the sorting probably. And then you need to get the name of the team. And what else? So you want to see cost probably, right? And then you also want to see the expected points, of course. So we will get the round. So I will round it to a certain amount of digits. So I will say LP, and then here again use next game week points, and then make this an F string. and let's round this to 2 digits of significance, and then is lineup. Now we are using is lineup, is captain, is vice. I think this is all. And once we have this data, what we will do is I will create a data frame called pix data frame, and I will this one, but this one, and then I will use pix, and then I will give names to columns. I will say name of the player, position of the player, this is the type of the player, numeric, team name, and then the price, team name, and then the price, and then the points. So this is XP, and then lineup, captain, vice captain. And so if we have this information, yes, and let's print the final solution. So this is everything we know about the solution. So as you see, we have like squad players, like all the squad players listed, and then these guys are inside our lineup, and then we have a captain, a Kane, and then we have a vice captain mount, and we can actually sort this properly. Let me call this sort values, and then I think I need to pass by, and then we want to sort it by lineup first, so lineup players appear on top, and then type, and then XP maybe, and ascending property should be false, and then true, and then true, because we want lineup players to be on top, and then others should be in ascending order. Shift enter, shift enter. Okay, this makes more sense. So we have our goalkeeper, we have 4 defenders, 4 midfielders, and finally 2 forwards in our lineup, as you see. And then we have our bench players, our captain and vice captain are part of the lineup. So looks correct. I mean, so what you can do is you can print total XP now. So I will say expression sum, and then here use just lineup P plus captain P for times again merge data log, and here use P and then F string next game week underscore points for P in players, and let's print this. Oops, sorry, we need to get the value. So let's get value, and then you see the total XP is 62.30, and then you can even get the total I think we called it price, right? Yeah, price. So you can even print the team value of this selection, and then when we print it, it is 99.8 with some numerical issues. But yeah, I mean, we completed the single period FPL problem. Now what we can do is we can actually convert everything into, let me save this, and then we can convert this entire thing into a Python script so that we can call it every time we want. So like, and then what you will do is then you can replace the CSV file every week, and then you can call the Python script directly. For this purpose, I will be clicking export as we don't have Python. Apparently not. Okay, so then I will just create a new under notebooks. Let's create a new folder. I will call this source src, and then I will call this single period dot py. And now what I will be doing is I will come here, and then I will move everything into this new file, and then I will copy this here, and then we don't need the prints and everything, so I will be skipping those. And actually, let me, while we are moving everything here, let me call this a separate name, with a separate name called maybe get data, so that we can actually call this as a function instead of like running it at the runtime. So maybe we can do it multiple times too. Here, I don't need this anymore. So here we are getting the element data. Here, team data. And then what else? Elements team. Remember this, we were combining elements and team here. And what else? We were getting the FPL review data here. And then we were merging them. We were setting the index in place. Get the next game week. And some of these we need to return from this function. And we need to get the type data, and I think that's all. I think. Yeah, so here I will be returning some of these as a dictionary. I will say merge data is merge data itself, and then team data is again team data, because we need these some of these tables for getting the indices and everything. So I will return type data, and then next game week I think we are using it inside some constraints. Okay, so get data function is completed. Now that's the second one is sol single periods FPL, and then I will make budget a parameter, an argument to this function, so that we can pass different budgets to see how the optimal solution and optimal value changes. Yeah, the first thing I will do is data is equal to get data, so I get the data information at the beginning, and then I will say merge data is coming from merge data. Let's copy this, type data, team data. Next, so this will be, wait, team data is equal to team data, and then we have type data is equal to type data, and finally next game week is equal to next game week. Okay, so and now we can get our indices here before we even start defining the problem, and now we can start the problem definition and everything here. Model, and then we have our variables, and I will choose them and press tab so that they will be aligned properly, and they will all go inside the same function. Squad count, sure, here, and then here. Okay, yeah, so we switch to constraints, right? By the way, we finished this one. Yeah, we are now creating the Python script. We don't need a semicolon anymore. Let me write variables and then constraints so that it will be easier for us to see what's going on. Here, another constraint. Two more. Actually, let me delete this. And here we have line type, lineup type count as a dictionary. Similarly, we have the same thing for squad, and I will move this constraint here, and then squad constraints here. What else? So we have the budget constraint, and remember budget is now a parameter, so we will get it from the function definition. But I can keep the price because it's how I calculate the team value, or how much it will cost me to create a squad like this. And then here you have team limit constraint, and then we have total points as an expression, and finally we are setting it as an objective. So one thing to note here is this command will no longer work in this format because this is special to Jupyter Notebook. So instead you need to call OS system and then command inside. And then we already imported OS here, so this should work fine. And also another thing is, like, every time we are now calling this function with a budget, I mean, and we are overwriting the same file, and as you see also here, so it is better to add budget here at the end of the file, so they won't collide with each other. If you will see that, but I mean, if we are solving the multiple of these problems at the same time, we don't want the solutions to overwrite each other, so I will be using it. And here again you are getting picks and everything. Oh god. Okay, peaks as a data frame. And am I returning it? Do I need to get anything else here? Oh yeah, total XP. We can also get the total XP and return it probably to the user. Okay, after we solve everything, I mean, you can even print this, right? So you can say print and define an f string, say total expected value for budget, and then use budget, and then define this as total XP. Yeah, we will see the value, and then we can return model if we would like to do anything else with it, and then picks as a data frame, so maybe you can write it to a file if you want, as a CSV file or anything you want. Yeah, I think we are ready. So we created the Python script, so only thing we need to add is if name is equal to main, so that this is how we will be calling the Python function directly. So we would like this if condition to be active only if we are calling the file directly. So I will say solve single period FPL with 100 budget. Okay, save this, click terminal, click new terminal, and then you will see a new terminal appearing here. Let's see if we have Python here. Yep. Okay. Let's clear this and enter source, and then call Python, and then single period.py. Let's see. Okay. It ran fine. So optimization is even called, but we get the file not found error because when we are opening this file, we need to add the f so that it's an f string, and then the budget can be replaced. Again, let me clear this, call this again. Okay, so it says total expected value for budget 100 is this 62.30, and let's change this. Suppose I have more money to burn, 110, and let's call this again. Oh, it's the same. Let's see. What about if I have only 90 though? Okay, now we get a different solution. Okay, perfect. So as you see, I mean, it doesn't take even long. I mean, it just goes very quickly. Suppose you would like to solve this problem for different budgets for some reason. I mean, it doesn't have to be budgets, by the way. I mean, you can do it for any purposes you want. You might want to force a certain formation. Maybe you can for certain team players. I mean, those constraints are very easy to add. But suppose you would like to solve, like, I don't know, like 10 problems at the same time, or not at the same time, but you would like to solve 10 problems and see how they compare with each other for some purpose. So what you can do is then is, instead of calling this directly, you can call this results, and then you can say, for example, I will do this for budget, but doesn't have to be for budget in range 80, and let's go until 120, and let's go 5 by 5, so it will go budget 80, 85, 90, 95, all the way to 120. Here, call R as the solve single period FPL problem, call budget is equal to, well, budget, and results append. So once we have the result, add the budget again, and get we would love to get the total XP, right? So I will return this here actually. Total XP is total XP, and get here our total XP. Okay, so we will append it and finally convert it to a data frame, and the columns will say budget and then XP, and I will print this data frame at the end. Let's see. Now you will see that it's entering and exiting, and you will see that the files are popping up here. Let me close this, and let's see what's going on here. Yeah, at the end you see the data frame here. So if you have only budget of 80, the maximum XP you can reach is 57.37, and then it increases slightly, and after 100 actually it doesn't improve at all. I think it's only changing the bench players probably, but the optimal 11 is actually the same after 100. But anyway, so this is a good practice, and as you have seen, it took a while. Let me calculate how much time it took actually. So I will call time.time, which gives me a timestamp here, and after printing the thing, I will say print time.time minus t0, so it will show me how many seconds has passed spent in for loop. So yeah, we will talk about two things in a second. The first one is parallel processing, because as you see, like, we are solving these problems one by one here, and it's taking a little bit. We can improve this by some tricks. So as you see, it's 13 seconds. So this is our benchmark. Okay, so we are trying to reduce this time to a better number. It doesn't have to be super fast, but if you are solving these problems like hundreds of times with different parameters and everything, this could be a little bit too long at the end for you. So what I'm going to do now is, from concurrent features, I will import something called process pool executor. So process pool executor is actually going to create a new process for every budget request that I have here. Yeah, and instead of calling it using os.system, so this will, as you expect, this is calling the system command, and it will cause us some problems if we would like to do the parallel processing. For this purpose, I will use another package called subprocess, and I will import two things, popon and devnull. The second one is needed if you don't want to see all these logs coming from the solver itself. So instead of calling os.system here, I will comment this out so you can find this in the final version when I upload this to GitHub. So I will call popen, so this is process open, and I will call the same command. I mean, this is because this is what we will do. And now, oh wait, think. Did we do a mistake here? Single period.mps. So this should be budget, right? So this should go like this. Oh yeah. Sorry. So we were only generating a different file for the budget, like the solution file, but I will do it for the MPS problem too, because when we are putting them inside a parallel processing scheme instead of a for loop, there is a chance that like some of the higher budgets will overwrite the file, so we would like to prevent it. So we will define a new file name for everyone, and here I will use command inside, and I will say shell is equal to false, and then finally I will direct this output into this devnull, which will make it just it won't appear in our console, and if I add wait, it will wait until the process is completed. This is exactly what we were doing with os.system. And in here, instead of a for loop now, I will copy this, but I will also comment out. Again, we will have results as a table, but sorry, we won't actually have this. We will only have the budget in this way, and here instead of actually let me do this. Budget will be equal to this as a list. I will convert this to a list, and then here I will say with process pool executor, and then you need to give a maximum worker. So this is the maximum number of processes that can run in parallel. Let's make this, I don't know, like 16 as executor. And here, instead of calling the function directly, what we need to do is we need to get the responses from executor.map. And map is going to map every value in this budget with this function this way. So you need to give the function name, and then you need to give the iterable. Like in this case, we have a list. So this every list member will go and fed into this function, and then we will collect responses here. So once we have responses though, so we can actually call this all results. So these are the all XP values, let me call this, and we can get our total XP for R in responses, because we don't want the actual response returning it's returning the entire thing, but we only need the expected points, right? We will get expected points, but as you see, we were putting budget together with the XP, right? So we can do the same thing this way. So we can use a function called zip. So I will say results is equal to zip, and then I will use budget with all XP values, and it will match them one by one. Now again, we can call this results budget XP, we can print it, and we can see the final runtime. I think we are ready. So we added parallel processing now. Let's see if it is working. As you see, they started almost at the same time and then finished at the same time, and 7.5 seconds is our new runtime. So the next thing is we are gonna do is detecting where we are spending our time. In here, like when we are using get data, and notice that the first thing we do is calling this API multiple like every time for every problem. And notice that this get data doesn't actually change. I mean, it's the same thing. So we are merging the data again, and then getting the teams, and then the types, and then finding the next game week. This whole step is same for every instance. So for this purpose, what you can do is either you can move get data here, like before the loop, and then use that data as a parameter inside here. Or another way is, if you would like to do it in a fancy way, you can actually call from function tools, you can import what we call an Lru Cache. So this thing is a decorator. You can edit it this way, and then I will say max size equal 1. So what this is what's happening here is this function, every time instead of like running it to the fully, we will cache the results. And I'm saying that 1 because this value doesn't change, but if you have a parameter, you can define a different max size. So this is the size of your cache buffer. So how many times you would like to remember, or how many different parameters you would like to remember this function for. And since we don't accept any parameter for this function, I mean, we can say max size equal to 1. And this way, when we are solving this, they will actually use the cached value. So that's why we have this task caching the data function. Let's see again if it changes anything at all. .53, and I think, I mean, slightly better, but there's a possibility that like all of them are calling it at the same time before any of them returns. So what I'm gonna do then is I will get data here by itself. Let's see if this will change anything. Well, it didn't affect as much, but if you have your data step like involving lots of processes in here, I mean ours is short, but the big benefit we have is we don't need to do this request multiple times, which could be problematic if you are requesting a website multiple times at the, originating from a single machine, you can get denied access. But anyway, so this is a cool trick that you can use. You can cache results of functions. So you can use the same trick here. If you are using the solution of this function somewhere else, you can add Lru Cache to this function as a decorator, and you can cache the return values, this model and then pix, data frame, and XP. So I will leave this part too, so you can actually see how the different implementation looks like. And done, done, done. So we actually covered everything related to single period FPL optimization problem. Here, obviously, since this is a single period, we don't have transfers, we don't need to deal with any chips or whatsoever. In the next video, we will be talking about multi-period FPL optimization problem, and I will build it on top of this. So I won't be starting from scratch. We will get this file, we will copy it, and then start editing it so that not only next game week is being used, but we will also use further game weeks, maybe like 3 game weeks of data inside the same problem with transfer variables and everything. And that's all from me for now, and thank you for watching.